Okay, good morning. So today is module 8 and it's about a network layer. So we are progressing, or we are moving through the OSI model. We first talked about the physical layer, the data link layer, and today we are going to talk about the network layer. Um, these are the topics that we will discuss. That is the network layer characteristics, IPv4 packets, IPv6 packet, how a host routes, and the routing table. Network layer characteristics. What are the characteristics of the network layer? Um, so this is the OSI model between two end devices hosts, you can see. So the network layer is the layer 3 of the OSI model. The network layer provides services that allows end-to-end exchange of data. Because of the network layer, end-to-end devices can exchange data. And the protocols that reside at the network layer, you can see there are two protocols at network layer, IPv4 and IPv6. These are the two protocols at the network layer. And the network layer also performs 4 basic operations, that is addressing end devices. It addresses end devices, it encapsulates packets, it does routing, and then it does the encapsulation. These are the 4 major operations of the network layer. So this is the IP encapsulation. Encapsulate the transport layer segments. If you look at the layer, from the transport layer, you go to the network layer. So whatever is being handed over by the transport layer is going to be encapsulated by the network layer. Whatever is being handed over by the transport layer, you can see this is the transport layer encapsulation. At the transport layer, you have the segment header and you have the data. So all this segment and the data is encapsulated, and then the protocol data unit is passed to the network layer. So this is the entire data. At the network layer, you add the IP header information, that is the source and the destination IP address. This is called encapsulation. The characteristics of IP, IP is connectionless, best effort, and media independent. These are the characteristics of IP. So we look at them one by one. What do they mean by connectionless? It is connectionless because it does not establish connection with the destination before sending data. That means it does not establish connection with the destination before it starts sending the data, and there is no control needed. The destination will receive the packet when it arrives, but no pre-notification. That means it's not going to alert the destination before sending that data. Okay, the best effort. What is best effort? Best efforts mean that the IP will not guarantee that this particular packet is going to be delivered. There is no guarantee in that. Okay, there is no guarantee that the packet is going to be delivered. Okay. Media independent also. IP is unreliable. It cannot manage or fix undelivered or corrupted packets. That means if a packet is corrupt, IP cannot mend that, or it cannot fix undelivered one. IP cannot retransmit if a packet has an error. IP cannot realign out of sequence packets. You see all this, what this sequencing means. IP must rely on other protocol for these functions. You can read all these things by yourself. You get to practicals. So IPv4 packets. Let's move to IPv4 packets. IPv4 packet header. This is the primary communication protocol for the network layer. The network header has many purposes. It ensures that packet is sent in a correct direction. it contains information for network layer processing. And the information in the header is used by all layer 3 devices that handle the packet. This is the example of the fields that are in the IPv4 packet header. These are the fields. But the most important ones are the source and the destination. Okay, so this is an example of an IPv4 packet header. So you are going to read from the left to the right. You can see the version, the internet header length, you have the identification, time to live. So all these things are important. You can read them and understand what is their functions. But the most important ones are source and destination IP address. So you can see the function of each of them. The version determines whether the header or is the packet is an IPv4 or the IPv6. You know, you also have the differentiated service that deals with the quality of services. The header checksum checks for corruption or whether there is an error in the packet. Time to live will count the hops. You know, when it becomes 0, then the router will discard the packet. Protocol will also indicate what type of protocol, whether it is ICMP, TCP, or UDP. So you also have the source and the destination IP address. This is an IPv6 packet. So IPv6, because of certain, why are we introducing IPv6 is because there are some limitations in IPv4. As a result of those limitations, IPv6 came into being. One of the limitations is IPv4 address depletion. That means the world is running out of IPv4 now. And again, another limitation is there is lack of end-to-end connectivity. When we go into private IP addressing, that's the time you will see this lack of end-to-end and also network address translation NAT. Increased network complexity. You know, NAT is meant for a temporary solution, but creates issues on the network as a side effect too. So these are the limitations of IPv4. That is why we move into IPv6. So IPv6, it has 128 bits, okay, instead of 32 bits for IPv4. So there are a lot of IPv4 6 addresses. You don't need to do network address translations, NAT. You don't need NAT, you don't need private IP addresses because you have up to 1 decillion addresses. This is, you know, more than what we need in the world. So you have no problem with IPv6. So this is how the IPv6 header will look like. You can see it in the IPv6 header, some fields are already removed. So it makes it very simple, but the source and the destination are very key. So these are the meaning of each of the fields in the header. You can read them and understand them. So where's that? Okay, now let's go to how a host routes. These are very important. I mean, you have to pay attention here. Host forwarding decision. How does a host forward packets from itself to a destination? Okay, first they said packets are always created at the source. Assuming this PC1 is the source, the packet is created. Each host device creates their own routing table. A host device will also have its own routing table. First thing the host will do, a host will send a host can send packets to either itself or to an IPv4 address or to an IPv6 address. These are the 3 possibilities. Local host, destination on the same, you can see these are the 3 possibles. First, it can send it to itself, IPv4 and IPv6. A host can also send to a local host. That a local host means a device in the same network or the same LAN with the sending host. It can also send to a remote host. What is a remote host? A remote host is a device that is in a different local area network. Okay. An example here is when this PC1 sends packets to itself, it is sending to 172.0.0.1, or it can send it to another host in the same local area network. This PC1 and PC2 are in the same local area network. The third one is PC1 can send it to a remote network. So this is the continuation on the same concept. So default gateway, you will see default gateway a lot. You need to understand these things because very soon we are moving into routing. Okay, what is a default gateway? A router or layer 3 switch can be a default gateway. What is a default gateway? A default gateway can be a router or a layer 3 switch. What is a layer 3 switch? A layer 3 switch is a box that does the functioning of switching and routing. Okay, features of a default gateway. It must be an IP address in the same range as the rest of the LAN. Your default gateway will be an IP address that should be in the same range with your host device. Okay, it can accept data from LAN and it is capable of forwarding traffic. When your host devices want to send data, first they have to send it to the default gateway if that packet is meant for the remote network. It can route to other networks also. Pay attention to all this. We will do a small lab on this. You can see a host to a default gateway. A host to a default gateway. So this is a local area network, this circle here. This is a local area network. So the default gateway here is going to be the interface of router 1 is going to be a default gateway here. Okay. Sorry. So every host device has a routing table. This is an example from a Windows PC. In your Windows PC, if you type netstate-r, that is going to give you the active routes, all the connections that your computer have established. Introduction to routing. Pay attention to this one also, is very important as a basics. Introduction to routing, we talk about packets forwarding. How does a host device forward a packet to a remote device? First, if PC, no, okay. Okay.
Yeah, I'm there.
Okay, sorry for that interruption. Okay, so here we are talking about how does a packet, how is a packet routed? If you look at this diagram here, I mean, this computer, PC1, is trying to send a packet to PC2. But between PC1 and PC2, we have several networks there. There are 2 routers. So the first network is this one, and there is a second network and third network. In this diagram here, we have 3 networks. So when PC1 wants to send information to PC2, the first thing is the PC1 is going to send this information to the default gateway. So the default gateway is at the interface gigabit 0/0/0. That's the default gateway. So the moment this PC sends these packets to router 1, what router 1 will do is, router 1 is going to check the destination IP address. So you can see the destination IP address is 10.1.1.0. So router 1 is going to check in its routing table. This is the routing table of router 1. Can you see it? This is the routing table of router 1. So router 1 is going to check its routing table. And when router 1 checks in its routing table, router 1 will realize that 10.1.1.0 network is connected via router 2. So router 1 is going to forward this packet to router 2. So when the packet arrives at router 2 will also check the content of its routing table, and router 2 will realize that this network is directly connected to itself. So router 2 is going to deliver the packet to the particular destination. So when moving forward, routers routing table. There are 3 types of routes in the routing table. These are the basic, but when we get there, you will see all this. There are 3 types of routes in the routing table. First is a directly connected route. What is a directly connected route? Directly connected. These are routes that are automatically added to the routing table because these are networks that are directly connected to the router. You have another one, remote ones. There are 2 types of remotes. That is one that is learned manually with a static route, and the other one that is learned dynamically using routing protocols. Okay, the last one is a default route. This forward all traffic to a specific direction when there is no match in the routing table. In the default route, if a router cannot find a match in its routing table, the router is going to use the default route. Okay. I think we'll activate another one to give you just a small lab on this. So look at an example of a static route. This command here is an example of a static route. If you look at this diagram here, we have R1, R2. The directly connected networks on R1 is 192.168.10.0/24 and 209.165.200.224/30. These are the directly connected networks. So automatically this router 1 will find these networks in its routing table. But for this router to know about this network that is 10.1.1.0/24, you can do it using a static routing. This is the command for static routing. In fact, I may take this diagram as an example when I'm giving you the lab, okay? This is a small one I can give you. So IP route 10.1.1.0, you give the subnet mask and you give the next hop IP address, okay? So another one is dynamic route. Dynamic route, with the help of the routing protocols, you can discover remote networks, okay? We will look more into all this. With the help of the routing protocol, you discover remote networks, and it can maintain an up-to-date information. It can choose the best path to the destination. So this is this diagram you see here. This black area is called the routing table. To check the routing table of a router, you issue the command show IP route. When you issue this command show IP route, you see this all informations here. You can see there are different alphabets. They are telling you that L means local, C means connected, S means static, R means RIP. So you need to know all this. These are all different types of routing protocol. So this is the content of the routing table. You see S star is a default route. Wherever you see S and star is a default route. Okay. Wherever you see L is a directly connected local interface. Wherever you see C is a directly connected network. So this is all for today. Guys, just give me 10 minutes. I will go. Oh my God, all these people are hanging here. You're all late. You're all late. Come on, Ami.
Yes.
I said, yeah.